Okay, one of the type of probability questions that comes up in your homework that I haven't went over yet is something like this. So let's say we have 3 urns. And urn 1 contains 5 red balls and 3 black balls. So 5 red and 3 black. And then urn 2 has 3 red and 1 black. And then one more urn 3 has 4 red and 2 black. Okay, and then the question is, if an urn is selected at random and a ball is drawn, find the probability it will be red. Okay, so an urn is selected at random. And a ball is drawn. And we want to find the probability that ball is red. Okay, so here's my problem. Now, what creates a little bit of a problem for us is this problem would be much easier if it was just one big urn and had all of these balls in it, and I said, what's the probability that a single, if I reach in and grab a single one, what's the probability that ball's red? How would you do that?
We'll add them all up.
Yeah, how many red balls are there total?
12.
12, and how many total balls are there?
18.
And then it would just be that, right? So what makes this one a little bit more difficult is because each of these urns has a different number, right? And we don't know which urn we've selected, okay? So one of these urns is selected at random, then I'm going to reach in and grab a ball, and then what's the probability that ball is red, okay? So what is the probability that I choose urn 1 versus urn 2 versus urn 3? What is that probability? 1 out of 3, okay? So the way I want you guys to maybe visualize this is I'm going to draw a little circle here, and we have a 1 1/3 chance of being in each of those urns, right? So maybe I'll do something like that, and this is urn 1, and this is urn 2, and this is urn 3. Okay? So we have a 1 in 3 chance of being in either of these urns, or these urns being selected. And then within each urn, it's segmented, right? So urn 1 contains 5 red and 3 black. So if I split this up into 8 equal segments, 5 of them are red and 3 of them are black, okay? And then urn 2, we have 4 segments, where 3 are red and 1 are black. Okay, so I'm going to try my best to do this. So urn 1, I'm going to try to split up into 8 segments. 1, 2, 3, 4, 5, 6, 7, 8. And we have red, 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 black, black, black. Everybody see that? It'd be nice if I color these, but urn 2, we have 4 segments, 3 red, 1 black. So 1, 2, 3, 4. We have red, 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 and black. And then finally, urn 3 has 6 segments, where 4 are red and 2 are black. 6 equal segments. 1, 2, 3, 4, 5, 6. And red, 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 red. 2, 3, 4, and 2 black. Okay? So now here's my problem. So try to imagine or visualize all of these black segments are black and all of these red segments are red. Okay? And maybe let's say I had a dial and I'm going to spin that dial. What's the probability that dial lands on red? That's what the problem's become now. Okay? So what we want to visualize is you have a 1 1/3 chance of being in each of these, and then once you're in each of those, it has a specific area that's red versus black. Okay? So the way you handle a problem like this is you have to visualize and look at each section. So the way I do the probability of red is I have a 1/3 chance of being in urn 1, And then if I am in earned 1, what's the probability of red? Well, you have 5 red, 3 black, so you have 5 out of 8. Okay? Then you do plus. It's like, if you guys could visualize all of the red areas, I'm adding all of the red areas. Okay? So 1/3 of it, 5/8 is red. Go to earned 2. I have a 1 in 3 chance of being in earned 2, and 3 are red, 1 are black, so 3/4 of that is red.
That's in column 2?
Yeah, that's earned 2. And then plus, I have a 1 in 3 chance of being in earned 3, and earned 3, 4 red, 2 black, so 4 out of the 6 are red. Okay? And that's how you attack a problem like this. So I think it helps if you visualize, you're trying to figure out if this whole thing is 100%, what percent of this is red, okay, out of the 100%. And this is how I attack that, okay? If you add that up, it comes out to, according to my notes, 49 out of 72. And if I approximate that in decimal, I don't know, you guys tell me, point something. 6?
6806.
806? Okay. All right, so there's a few homework problems sprinkled in that are very similar to this. You have a specific percentage chance of being in different areas, and then what's the probability of what you're trying to find in those different areas. So you split them up and add them up. Okay? Okay, great. The next thing that we want to talk about is a tree diagram. Okay, a tree diagram, it's pretty easy. It's basically a device used to list out all possible outcomes. Okay? Let's take a look at this first example. A quiz contains 3 true and false questions. List, using a tree diagram, every possible answer key. Okay? So we have a 3-question quiz. 3-question true or false quiz. And we're going to use a tree diagram to list every possible outcome or every possible answer key. Okay, so the way a tree diagram works is you start with what we call a node, which is just a circle that is closed or filled in. And then with a question, 3-question true or false quiz, I start with the first question. So what are my possibilities on question number 1? It's either true or it's false, right? So then I start branching out. This is my first branch. First question is true or false. Okay? Then once I've done the first question, I move on to question 2. And again, for question 2, my possibilities are true or false, right? So the first answer could have been true, but then when we go to the second question, you still have a possibility of true or false. Okay? And then again, one more time, if I go on to the third question, again, the possibilities are true or false. So I've kind of made this a little ugly, but you extend on each of these with a true or false. Okay? And I've listed every possibility. Now, to develop the answer keys or write those down, you just have to make sure you go down every single branch. Okay, so if I go down the top branch of the tree, you get true, true, true. Then the next one, true, true, false. Then the next branch, true, false, true. So it's a systematic way of listing out everything. Then true, false, false. False, true, true. False, true, false. False, false, true. Click in here. And then finally false, false, false. Okay? So a tree diagram, again, it's used to list out every possibility in a systematic way. Okay, so go down every branch and that will list out every possibility. All right, let's try another one. Let's say two teams are doing a tournament where it's the best 2 out of 3 is the winner. Let's do a tree diagram. All right, so we have Team A versus Team B. Best 2 out of 3. Okay. The first team to win 2 games is the winner of this tournament. So let's do a tree diagram. All right, we play game 1. What could happen with game 1? Who could win? Team A could win, or B could win. Let's assume no ties in this particular example, because I wouldn't know what to do. Okay. We play a second game. Who could win? A could win, or B could win. A could win, or B could win. Okay? Now we have to be careful here. I could play a third game, right? But would I play a third game if A won the first game and A won the second game? No, that one's done. Does everybody see that? So if A won the first and the second, then the tournament's over. A's the winner. Okay? But if A won the first and B won the second, then we would have to go to a third game. And then it would be either A or B. Okay? Similarly down here, if B wins the first and A wins the second, that would extend to a third game. A could win or B could win. But if B won the first game and B won the second, then that branch is complete. All right? Then again, to list them all out, you systematically go through each branch. These are your possibilities. AA, ABA, ABB, BAA, BAB, and BB. 6 possibilities. Tree diagram. Okay. Tree diagrams are really, really awesome. They're really great, but you really only want to do it with smaller outcomes, right? If I flip a coin 100 times, I don't want to do a tree diagram for that, okay? 2 or 3 times, all right, I'll do a tree diagram, but not 100 times. Okay. All right. We're starting what's called counting techniques. So I want to do the first little section on counting techniques. And the first rule we have for counting techniques is called the multiplication rule. So this is called the multiplication rule for counting. Okay, so basically let's look at an example first because I think it's easier to see with an example. So let's say a woman has 3 skirts, 5 blouses. So example 1. A woman has 3 skirts, 5 shirts, and 4 pairs of shoes. And the question is, how many different outfits are possible? Okay, so if we consider 1 skirt, 1 shirt, and 1 pair of shoes as an outfit, how many different or how many unique outfits can we come up with these 3 skirts, 5 shirts, and 4 pair of shoes? Okay, and this utilizes what is called the multiplication rule. Okay, so to get the total number of outcomes or the total different things here, we have the number of possibilities times the number of possibilities times the number of possibilities. Okay, that's why it's called the multiplication rule. So with skirts, how many possible skirts do we have? 3. With shirts, how many shirts do we have? 5. And with shoes, 4. Okay? So to get the total number of different possible outfits, you're just going to multiply these together, and you have 60 possible outfits. Okay? And that's it. Relatively easy. What about that first tree diagram problem we just did? What was that question? How many what? We had a 3-question true or false quiz. And we wanted to know how many possible answer keys we had, right? So for question number 1, how many possibilities do you have for an answer? 2. Question number 2, 2. Question number 3, 2. So if you go back and look at your tree diagram, you should see that we came up with 8 possibilities. Okay? This is the formula that you want to use for flipping a coin 10 times, right? It's just 2 times 2 times 2 times 2 times 2, as opposed to trying to do a tree diagram to list everything. Okay? Okay. Now we're going to get to problems that are definitely on your test. Your second test, not the first test. And I call these ID card problems. Okay, so let's look at ID card problems. So we need to distinguish between repetitions allowed or repetitions not allowed. What does it mean for repetitions? What does that mean? It just means you can repeat, okay? So there's going to be a difference if we're allowed to repeat numbers or letters versus if you're not allowed to repeat numbers or letters, okay? Okay, let's do an ID card problem. So let's say we have an ID card, and it consists of 3 letters and then 2 digits. Okay? So here's my example. I have an ID card, 3 letters, and 2 digits. For example, it could be ABC01. That could be my ID card, right? What's another one? Give me another one, for example.
ABC02.
Okay, sure. ABC02.
Creative.
Right? So any 3 letters, you know, CWZ 35, whatever. Okay, this is my ID card. Okay? All right. So question number 1, how many possible?
Super creative.
With repetition of letters and digits. So again, what does that mean? That means you can repeat letters and you can repeat numbers. So for instance, AAA22 could be a card because you're allowed to repeat the letter and you're allowed to repeat the number. Okay? How do I do this? Well, we just go right back to our multiplication rule. The number of possibilities times the number of possibilities times the number of possibilities. So, in the first spot, it has to be a letter. How many possibilities do I have for this letter? 26. I'm allowed to repeat, right? So how many possible letters do I have for my second spot? 26. 26. What about the last 2? 0 through 9, there's 10 possible. Right, 0 counts. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's my answer. Okay? All right, let's take a look at question 2. Let's say letters cannot repeat, but numbers can. How does that change my answer? Letters cannot repeat, but digits can.
Would it be 26 times 25 times 24?
Exactly. Once I use a letter, I've taken that letter out, so now I only have 25 possibilities for the next box, times 24 possibilities for the third. Okay? Digits we said could repeat, so that goes back to 10 and 10. And that's it. Okay? Good. Let's try another example. All right, let's say a radio station call sign must be K or W, followed by 3 digits with no repetition of letters, but you can repeat digits. Okay? How many possible radio station call signs can we come up with? So it has to be a K or a W, and then 3 digits. So what am I going to get here? How many possibilities do I have for the first?
2.
2. And then I go to numbers, right? And how many possible numbers do I have?
10, 9, 8.
Am I allowed to repeat?
No.
It says no repetition of letters, but I've only used one letter when there's no more letters, and now it's numbers, right?
10, 10, 10.
So this would be 10, 10, 10. Okay? Now let's say it's 2 letters and 3 digits. Okay, so this first question was just 1 letter and 3 digits. But now let's say it's 2 letters and 3 digits. So I have letter, letter, number, number, number. How many possibilities do I have for the first letter? 2. And then it says I'm not allowed to repeat letters, right? So I've used one of these letters. I've used a K or a W. How many letters do I have left? 25, right? Only the first letter must be a K or a W. This next one could be anything. But it can't be a K or a W because I've already used a K or a W. So does everybody see that that's 25? Because you used 1 letter, so you have 25 letters left. All right, 3 digits, they're allowed to repeat. So 10, 10, 10. So anything that I could come up with, I could say the letters don't repeat. The numbers do repeat. I could say the last number has to be a 5, right? I could say the first letter has to be an A. The second one has to be Z, W, or 6. You know, whatever. I could come up with anything. All you guys have to concentrate on is list out how many things we have, what are the total possibilities for the first slot, times what are the total possibilities for the second spot, okay? It always comes down to that. Any questions? Okay.